This will be lesson 1.1D, estimating irrational square roots. Okay, we will be working from standard, estimating irrational square roots. Standard is going to be 8NS2. Use rational approximations of irrational numbers, down here, to compare the size of irrational numbers, locate them approximately on a number line diagram, and estimate the value of expressions, for example, pi squared. So yesterday or last lesson we were talking about rational numbers and how to make them into fractions. Today we're going to talk more about the irrational numbers. So we are going to be able to, I can estimate irrational numbers. Take myself off of there for the time being. Okay. What is an irrational number? Do you remember? It's any number that cannot be written as a fraction. So remember that repeating decimals can be written as fractions, right? And non-terminating decimals that repeat can also be written as fractions. So let's see if we can figure out which ones are going to be irrational. Is 4 irrational? No, because it can be written as a fraction, 4 over 1, right? So it is a rational number. Is square root of 4 irrational? What do you think? No, because it can be written as 2 over 1, because the square root of 4 is 2, and you can put it over 1. How about 0.34 repeating? Is that irrational? That was from our last lesson. I hope you all said no, right? Because it can be written as not 33.99, that's an error, 34.99, right? Okay. Is square root of 2 irrational? Let's think about that. Is there a number you can multiply by itself to give you 2? There isn't a number, so square root of 2 is irrational. It cannot be written as a fraction. It does not repeat, and it does not terminate. It is an irrational number. Let's take a little bit closer look at that. What number can you multiply by itself to give you square root of 2? Think about it. Is there a number you can multiply by itself? So like for example, square root of 4, you can multiply, so let's put that in there here, square root of 4, you can multiply 2 times 2, right? So the square root of 4 is equal to 2, right? What about square root of, let's say 16? Square root of 16, is there a number you can multiply by itself to give you 16? Of course, 4 times 4. So square root of 16 is equal to 4. But let's look at square root of 2. Is there a number you can multiply by itself to give you square root of 2? Well, 1 times 1, that's going to be 1, right? That's not going to give you 2. And we already said 2 times 2 is going to give you 4. What about 1.5 times 1.5? Remember, you can square decimals. 1.5 times 1.5. What is 1.5 times 1.5? Anybody know? 2.25. 2.25. Well, that's a little bit over, right? That's not 2. A little bit over. What if we tried something a little smaller? What if we tried 1.4 times 1.4? What do we get then? 1.4 times 1.4. 1.96. That's not 2 either, is it? But it's close. It's pretty close, but it's not exact, right? What if we tried another decimal place? What if we tried 1.45? What's that going to give us? Times 1.45. 1.45 equals 1.45 times 1.45, 2.1025. So that's over, right? So we can't find a number that exactly gives us 2. So the square root of 2 is irrational. So let's see, how do we estimate for this? Let's see. There is no number that you can multiply by itself to give you exactly 2. So if I was to take my calculator and type in 2 and hit that square root button, remember that looks like this, square root of x, right? That's the button on your calculator. So you type in 2, and then you hit square root of x, you're going to get this long number in your display, depending on how many spots your calculator will show. You're going to get 1.41421356233731, and it's going to go on forever and ever. And notice that it is a non-terminating decimal. It's non-terminating. But is it repeating? No. So it's non-repeating. So there's no pattern. Like the 414 part, the 1.414, that 414 doesn't repeat. 414, 414, 414. And nothing in this number has a pattern at all. So it is irrational. It doesn't make sense. So if you were to multiply 1.414, let's just go that far. Let's cut it off at the spot right here. If you were to multiply 1.414 squared, you're going to get very close to 2, but not exactly 2. So take your calculator and type in 1.412 and hit the x squared button. Remember, that's a button on your calculator that looks like this. So type in 1.414 and then hit the x squared button. You will find that you get 1.999396. That's not exactly 2, but it's very close approximation of square root of 2. But it's not exact. Square roots of numbers that are not perfect squares, as I said, are called irrational numbers. They cannot be written as fractions. They do not repeat. They do not terminate. They go on forever and ever, but they never have a pattern, a logical pattern. Okay, it's your turn. Give it a try. See you back in a minute. Okay, how did you do? Hopefully good. Let's move on. So how do you, or how do I, meaning you, approximate square root numbers that are not perfect squares? How do you do it? Got to be a way, right? Let's approximate square root of 3. Because there is no number that you can multiply by itself to give you exactly 3. So let's see. Step 1, we're going to find 2 consecutive, that means next to each other, numbers that when squared will give you an answer with 3 in between both numbers. So we're talking integers here, so whole numbers, right? So we're going to give that, we'll give an answer between, with 3 in between both numbers. So let's try 1 squared. What's 1 squared going to give me? 1 times 1, right? Or 1. What's 2 squared going to give me? 2 times 2, or 4, right? And wouldn't you say that 3, the answer of 3 is right in between 1 squared and 2 squared, right? So we know that our approximation is going to be somewhere in between 1 squared and 2 squared. We don't know what. We want to get as close to the square root of 3 as we can. to a certain approximation. And in the problems, it will tell you what approximation. They're going to say, do you want to get to 2 decimal places, to 1 decimal place, to 3 decimal places? It will tell you how close of an approximation that they want. So, I mean, like, we could try 1.5. That's 1 decimal place, right? We could try, and it'd be squared, right? We could try let's say 5, 4. That's 2 decimal places, and then we square it. And we can see how close are we getting to 3, right? So we can try different things, but there's an actual method to this. I'm going to clear this. So what I just showed you, 1 squared equals 1, and 2 squared equals 4. So the square root of 3 is between the perfect squares of 1 and 2. Step 1 is to find those 2 consecutive integers where the number under the square root is between. So that's where I was saying it's a great idea to start memorizing. Like, there's a chart in the classroom. Start memorizing what 1 squared equals, what 2 squared equals, what 3 squared equals, what 4 squared equals, what 5 squared equals. Start memorizing them. 6 squared, what does that equal? Memorize your double, so to speak. 7 squared, 8 squared. I'd like you to go all the way up to 15 squared. So memorize as much as you can. It'll make your life a lot easier, all the way from 1 squared up to 15 squared. Okay, let's move on. So we know that this is the same thing from the previous page. Square root of 3 is going to be between 1 squared and 2 squared, between 1 and 2. So step 2 is going to be asking yourself, move my little toolbox here, is 3 closer to the answer of 1 squared or to the answer of 2 squared? Well, 1 squared is 1 and 2 squared is 4. Is 3 closer to 1 or is it closer to 4? Right, 3 is closer to 4 than it is to 1. So let's take a look on the number line. 1 squared is equal to 1. 2 squared is equal to 4. And the square root of 3 there is closer to 2 squared than it is to 1 squared. See where I put it there? I spotlight there. I put it right here, closer to 2 squared, right? So this is 1. This is 4. This is halfway in between. By the way, what's halfway in between 1 and 4? Let's go on. Okay, let's get that thing off the bottom there. 3 is closer to 4 than it is to 1. So what is exactly in the middle of 1 and 2? Well, 1.5 is right in the middle of 1 squared and 2 squared. So 1.5 squared is going to give me 2.25. That's 1.5 times 1.5. So again, I would rather you not be using your calculators unless you're just doing it to check right now. I would like you working the math through so you get really good at it so that you are math whizzes. So what you got to do to find 1.5 squared is do the time thing. 5 times 5 is 25. Carry my 2. 5 times 1 is 5 plus 2 is 7. I multiply 1 times 5 is 5. I'm just showing you how to do this in case you forgot. 1 times 1 is 1. Add up your 2 partial products. 5. 7 plus 5 is 12. Carry the 1. 2, 2, 5. We have one number after the decimal here. We have one number after the decimal here. So we have to have 2 numbers after the decimal in our answer. We're going to put our decimal right here. That's where 2.25 comes from. All right, let's move on. Okay, here's our number line from the previous page. We have our 1 squared, spotlight. We have our 2 squared. We have our 1.5 right in the middle between 1 and 2. We have square root of 3 over here, right? Okay, remember what we're trying to do is we're trying to figure out a number multiplied by itself that will give us 3 as an answer. Well, we're not going to have an exact 3. We want to get as close as we can. So step 3 then is going to be to find a better estimate using decimal graduation. So here I used 1.5. And that gave me 2.25. That's not very close. If you think about it, 2.25 is not very close to 3. I think we can get closer than that and a better approximation. So that's what we're doing. So we're going to find a better estimate using decimal graduation. So 1.5 squared is 2.25, which is what we have up there on the number line. So let's try 1.6 squared. What is that? That's going to give us 2.56. 1.7 squared is going to give us 2.89. 1.8 squared is going to give us 3.24. None of those are 3, but some are closer to 3 than others. So now we know if we did 1.5, 1.6, 1.7, 1.8 squared, 3 is going to be between 2.89 and 3.24. This is where knowing your decimals from back in 6th grade, maybe even 5th grade, are going to come in handy right now. So square root of 3 is between 1.7 and 1.8 squared. So if we were going to put that on the number line, trying to get rid of some of these boxes that keep popping up, we would have 1.6 maybe here. We could have 1.7 maybe here, etc. So you can see how you could divide your number line up. Okay, let's keep going. Okay, now we know it's between, actually let's go back one. Put that back again. Oh, I went the wrong way. I'm gonna go backwards. What is going on? What slide number was it? I think it was 8. Let's see. Yeah, it was. Okay. I want to go back to this for just a second. Okay, we decided that the square root of 3 was between 1.7 squared and 1.8 squared. Okay. So now step 4 is to find something even better. I'm going to write this up here. Between 1.7 and 1.8. And remember, what was 1.7 squared in the previous page? 2.89, right? 2.89. And then what was 1.8 squared? That one was over 3, remember? That was 3.24. 3.24. So we know that 3 was between these two numbers. I just want to keep that there so we know. Okay, so number line back. Oh, actually, we're going to have it there for us, but I don't need to write it again. 1.7 squared was 2.89, and 1.8 squared was 3.24. So we can take that off of there. I guess we need that. And we want to get something closer than 2.89 and 3.24. So we're going to pick the middle, right? So square root of 3 is between 1.7 and 1.75. Now, where did I get the 1.75? Well, one way of finding it is to do the middle. So 1.7, find the average of the middle, the very middle between 1.7 and 1.8. So to do that, I'm going to add 1.7 and 1.8. 7 is 15, carry the 1, 3. 3.5, right, when I add it, and then I'm going to divide 3.5 by 2. I'm going to divide it in half. That'll give me the exact center point of 1.7 and 1.8. So that'll be a good skill to use. Add up the two numbers, divide by 2. So 2 goes into 3 once. 3 minus 2 is 1. Bring down the 5. 2 goes into 15. Or decimal there. 7 times. 2 times 7 is 14. 15 minus 14 is 1. Let's add a 0 because you can always add a 0 and it doesn't change the number. Bring it down. 2 goes into 10 5 times. 2 times 5 is 10, and I'm going to end up with a remainder. I'm on a space here. I'm going to end up with a remainder of 0. So that's where my 1.75 came from. I found the average 1.7 and 1.8. The number right in between 1.7 and 1.8. Add the two numbers up on the left and on the right and divide by 2. And that gives you that. So if I square 1.75, I get 3.06. So you would be taking 1.75, and I want you to do this without your calculator. I want you to get really good at it. 1.75 times 1.75, right? You're going to multiply the 5 times each number, and you're going to multiply the 7 times each number, and then you're going to multiply the 1 times each number. I know it's a little tedious, but necessary. Right? So you would get 3.6 if you did that. So now, let's take a look. Square root of 3 then. Let's look at, we have 2.89 and 3.06. So now we're going to drop this one off because 3.24 is too high. So now we know square root of 3 is between this 1.7 and it's between this 1.75. So here's square root of 3 now. It's right in here. So now we're getting an even closer estimate. So 3.06 is pretty close to 3. So we are pretty close. Step 5 is we're going to choose our final approximation. So what are we going to pick? Are we going to pick 1.7 squared, 1.75 squared, or something in between those two? Move my little thing here. We're going to pick 1.73 squared. Now, how did I get that? Well, I just took a nice guess. So what you could do is you could, again, find the middle between 1.7 and 1.75. How do you find the middle? You add the two numbers up. The lower limit, oops, it should be a 5. The lower limit and the upper limit, right? So we add together the lower limit and the upper limit. 5, 7, and 5 is, or 7 and 7 is 14. Carry the 1. 3.4, that's supposed to be that. 3.45, and then we divide 3.45 by 2, right? To find the middle number, we divide by 2. And if we do that, again, we're doing it by hand. 3 minus 2 is 1. Bring down the 4. 2 into 14 goes 7 times. It becomes a 0. And I bring down my 5. 2 goes into 5 2 times. Okay, so 1.72, that's going to give me 4. And I subtract, I'm going to have 0 or 1, and then if I bring down a 0, it's going to be 1.725. Now our approximations only have to go to 2 decimal places, so we don't have to quite go to 1.275. So that is why I picked 1.73, because I only have to go to 2 decimal approximations, not to 3. And 1.725 is right in the middle of 1.7 and 1.75. So 1.73 squared will give me 2.99. That's almost 3. So that is very close. So square root of 3 is very close or close. Let me find my circle here. Square root of 3 is close to 1.73 actually squared, right? The answer, square root of 3, is close to 1.73. But remember, this is an approximation. It's not the actual answer because square root of 3 is irrational. Okay, it's your turn to give it a try. See you back in a minute. See if you can estimate some of these irrational square roots. Okay, how did you do? Let's move on a little bit. Let's try estimating another square root. This time, let's approximate the square root of 54. A little bit bigger number than square root of 2 or square root of 3. Try a little bit bigger number. There is no exact number that you can multiply by itself that's going to give you 54. So that's why it's irrational. So step 1, find two consecutive numbers that when squared will give you an answer with 54 in between both numbers. That's why I said memorize your squares up to 15. So if I can think in my head, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. Which one is 54 in between? Well, 7 squared was 49, and 8 squared was 64. And square root of 54 is in between the perfect squares of 7 and 8. So step 1 is to find that lower limit and that upper limit. Now we found a spot. So this is just drawing what we had on the previous page, showing that the square root of 54 is going to be between 59 and 64, or between 7 and 8. Now we ask yourself, is 54 closer to the answer of 7 squared or to the answer of 8 squared? Is 54 closer to 49, or is 54 closer to 64? What do you think? Do a number line. 7 squared is 49, 8 squared is 64. Right, square root of 54 is closer to 49 than it is to 64. So it's only 5 away from 49, and it's 10 away from 64. So now 54 is closer to 49 than to 64. There is the exact middle between 7 and 8, right? So how did I get that? How do I find the exact middle if I don't know? Well, I add up the lower limit and I add up the upper limit, and then I'm going to divide by 2. So 7 plus 8 is 15, and I'm going to divide 15 by 2, and that I can just do in my head. 15 divided by 2 is 7, which gives me 14. Bring down the 1 and the 0, so 7.5. If you need to do long division for that, feel free to do that. So 7.5 squared is the exact center of between 7 and 8. Then I want you to calculate 7.5 squared by hand. 7.5 times 7.5. And by the way, I belong to this math teacher group. Somebody was asking, when do you let your students use a calculator for their math? And so just about everybody was saying the second half of the 8th grade year. So that is what I am also doing. So we are all on the same page, us math teachers, about that. 5 times 5 is 25. Carry the 2, so we're going to do this by hand. 5 times 7 is 35, plus 2 is 37. And I multiply 7 times 5 is 35. Remember, you started under the 7 because you're multiplying by the 7. Cross that off. Make this a 3 now because we carry a 3 over. 7 times 7 is 49 plus 3, 50, 51, 52. And then we're going to add that up. 5. 7 and 5 is 12. Carry the 1. 3, 4, 5, 6. And then a 5. And where do I put my decimal? I have 1 after the decimal here, and I have 1 after the decimal there. So 2 spots. So that's where this 56.25 comes from. I do want you doing that. Okay, let's move on. We have now a new lower limit and a new upper limit. We have a lower limit of 7 squared, and we have an upper limit now of 7.5 squared, because now 54 is going to be between 49 and between 56. And now this one is dropping off. That was too high, right? So see if we can get any closer now. Okay, this is what we had before. Step 3 is find a better estimate using decimal graduation. So again, we're going to want to find, remember we crossed off this because that was too high. We're between these two. We're going to want to find the exact center between 7 and 7.5. That's what we're going to want to do. How do we do that? 7 squared is 49. 7.2 squared. Well, let me go back one. Let's first find the center. So we have 7. We're going to add 7.5. And then we're going to divide by 2. That'll give us the exact center. 5. Wind up my dot. 14. So 14.5, and we're going to divide 14.5 by 2 to get the exact center. And then we'll talk about the next thing that's up there in a minute. So 2 into 14 goes 7 times. 2 times 7 is 14. And down 5. 2 goes into 5 twice. 2 times 2 is 4. 5 minus 4 is 1. If I add a 0 and bring that down, 2 goes into 10 5 times. So 7.25 is exactly in the center. And then we would take 7.25 times 7.25 and square it, right? And we would get, I'll put it in parentheses here, 52. This is 7.25 squared. 52.5625. 5, 6, 2, 5. And you can see we are now going to have a different upper limit and a different lower limit. So 54 is actually higher than 52. So what would end up happening now that we have this new 7.25, what's going to happen is our 54 is going to be between 52, or this 7.25, and between this 56, or this 7.5 squared. So now we have a new lower limit and a new upper limit. So what I did here is I just started finding a better estimate. So I did 7.2 squared. I did 7.3 squared. I did 7.4 squared. And I found that 54 is between 7.3 and 7.4, which makes sense because up here, grab my spotlight here, up here I found the exact center of 7 and 7.5, and I found that my 54 is going to be between this number, 7.25, and 7.5, right? So that makes sense that it could be 7.3 or 7.4, and now I know that it's between these two, right? So pretty close estimates. Here are my drawings here. So now step 4 is to find an even better estimate. So we're going to find the exact middle. Let's put our number line back here. 7.3 squared and 7.4 squared now. Those are our lower and our upper limits because we figured that out. What's the exact center of 7.3 and 7.4? How do we find that? Exact center right here. Well, we add 7.3 and 7.4. Add that up. 7, 14, 7, 7 is 14.7, and we're going to divide that by exactly 2. I'm going to divide that by 2 to get the exact middle. Divide by 2. 2 times 7 is 14. 14 minus 14 is 0. We're going to bring down our 7. 2 goes into 7 3 times. Don't forget your decimal up there. 2 times 3 is 6. 7 minus 6 is 1. If we were to put a 0 there and bring that down, now we get 2 into 10, which will give us a 5. So 7.35, 7.35 is the exact center between 7.3 and 7.4. And 7.35, if you square it, is going to give you, and I'll put that in parentheses, 54.0225. I actually probably have this so the computer will write that, but let's just see. So now we know that 54 is going to be where? What's our upper and lower limit? Well, now we have change colors here. This will now be our upper limit, and this is our lower limit, right? Because 54 is going to be between these two numbers. So we would then drop off the 7.4. So let's see what we did here. Okay, they did put it up there for us, so let's clear this. So square root of 54 is going to be between, like I said, the lower limit and the upper limit is now this, right? So we're trying to find an even better approximation. 54.02 is very, very, very close, right? So choose your final approximation. We're going to choose 7.35 because that is very, very, very close to 54. So now when you do these problems for a test, you can have different approximations from another student, because your approximation may be slightly different by a few points. You might have 7.41 or 7.36, right? Those are all acceptable limits depending on showing your work and how you arrived at that. The key is, how did you arrive at your estimate? Okay, now it's your turn again, this time with a larger irrational square root. See you in a minute. Okay, now that I've shown you how to do it the long way, yes, there is a shortcut, but the shortcut will only work for numbers where you can do an approximation of 1 decimal place. So if you were approximating a number and you came up with 3.2, if you only need a 1 decimal approximation, this shortcut will work. If you need a 2 decimal approximation, so for example 3.25, the shortcut is not going to work completely. You're going to have to continue to estimate using the method I have just shown you. If they want something to 3 decimal places, let's say something like this, you're going to have to just continue using the method I've already shown you. But this shortcut will work for an estimate to 1 decimal place. So we're going to approximate the square root of 30, and like I said, for the shortcut, only to 1 decimal place. For the test, you're going to probably have to do 2 decimal places. So this method will sort of work to 1 decimal place, but you're going to have to know the other method as well. Okay, so step 1 in the shortcut is find the perfect square closest to 30 without going over. Similar to what we've done. We found two of them before. We found the lower limit and the upper limit. Now we're just finding the lower limit. So what number is close to square root of 30? Well, 5 squared is equal to 25, and 6 squared is equal to 36. Now 36 is over, right? This is our lower limit and our upper limit using the other method. So now this time we're only going to choose the lower limit for the shortcut method. So we're going to choose 5 squared because 25 is close to 30 but not over. Okay, that's step 1. Step 2 is we're going to divide 30, our number under the square root, by the number we chose, our 5 squared. So we're going to divide our number under our square root by our lower limit. I should probably type that in there for us. Divide number under the square root by the lower limit. Okay. So divide 30 by 5. 30 divided by 5 is going to be 6. Now we're going to find the average of the numbers 5 and 6. So we're finding the average of the lower limit and the answer we got when we divided by that lower limit. So we're going to find the average. How do we do that? We're going to add 5 and 6 and divide by 2. Add 5 plus 6. Oops, that thing showed up on the bottom. 5 plus 6 is 11. We're going to divide that by 2, and we're going to get 5.5. So 5.5, here's my color here, squared equals 30.25, which is very close to 30. So we're going to say that square root of 30 is approximately 5.5. Now this little symbol here means approximately equal to. It's not exactly equal to it, because we know there's not going to be a number that's exactly equal to 30. But 5.5 times 5.5 will give you 30.25. Now, like I said, if we wanted a closer approximation, like to 2 decimal places, we would then need to continue the method we've already learned, and we would have 5.5 here, right? And we would have our 5 here, 5 squared and squared. This was 25, and 5.5 squared was 30.25. And then at that point, if we needed to go 2 decimal places, we would then have to find the average of 5 and 5.5, find the exact middle right here. The exact middle, how do we find that? Well, we would add 5, and we would add 5.5, and we would divide by 2. So we would end up with 5 here and 10 here. We would end up with 10.5, and we would divide 10.5 by 2. That would give us 5.25. So 5.25, and then we would square that and see how close we were to 30. So 5.25 squared is 27.56. That's going to be 27.56. So now we know that we have a new upper limit, a lower limit, and a new upper limit, or same upper limit. And we would get rid of this, would drop off. So now we know our answer is between 5.25 and 5.5. So if you need to go further, after you get the shortcut method done, you'd have to continue to use the long method that you were learning before. Okay, now I believe I'm going to have you use the shortcut method. Yeah, I was just saying here, if you need to estimate the 2 decimal places, you may need to partially use the longer way at this point, which is what we just showed you. So now it's your turn to try the shortcut method. So give it a try. See you back in a minute. Okay, how did you do? Hopefully you did well. Now you get to try this on your homework. I'll come back on here. Here I am. Page 12, I want you to do 16, 17, 18, and 19. Notice the red letters without a calculator. I want you multiplying, I want you dividing, I want you knowing what you're doing. And then you're doing IXL, exponents and roots, F16, estimating or estimate positive square roots. Okay, I believe that is all I have for you for this lesson. We will see you next time. Bye.